All right, let's talk about something you use every single day, but probably never really think about. It's kind of this invisible magic that makes all your apps and websites just work. It's called data integration, and it's the secret sauce behind our seamless digital world. So let's kick things off with a simple question.
I mean, seriously, have you ever stopped to wonder how that happens? You click one button, and suddenly information from like a dozen different places just appears on your screen. It feels like a magic trick, right? But it's not. It's actually some seriously clever engineering.
A perfect example is a simple Google search. You type something in, and bam! Before you can even blink, you don't just get a boring list of links, you get a whole dashboard, right? A summary box, news stories, pictures, videos, maybe even a map. All that stuff comes from totally different databases, but it's all presented to you in one neat package.
Or how about when you're booking a trip? You pop your destination and dates into a travel site, and instantly you've got flights, hotels, and rental cars all lined up and coordinated for you. That is not happy accident. That is data integration doing its thing.
Okay, so we see the end result, but what's actually going on behind the scenes? How did these systems manage to combine all those different pieces of information from just a single click?
Well, at its heart, data integration is pretty much what it sounds like. It's the process of grabbing data from a whole bunch of different sources in all kinds of messy formats and then stitching it all together into one single unified view, the view that you see.
Now, this isn't done with some old-school database. Think of a traditional database like a super strict spreadsheet. Everything has to be perfectly organized with a unique ID. But the internet? It's not like that. It's a mess. So modern systems use something called a knowledge base. It's way more flexible, kind of like a web of info. It can handle all that unstructured data because instead of looking for perfect IDs, it groups things based on how similar they seem. And that flexibility is absolutely crucial.
And that right there gets us to the real challenge. To make all this work, we had to move way beyond those simple databases and tackle a problem they were never, ever built for: the beautiful, chaotic mess of real-world information.
So here's the thing. In the real world, most stuff, people, places, products, they just don't have one single universal ID that every system agrees on. Our digital world is swamped with different names for the same thing, with duplicates and with just plain confusing data.
Just take a look at this. Are these 4 different people, or are they all the same person? Now, you and I can probably guess they're the same, but how is a computer supposed to know that for sure? Without a unique ID, how can it tell? This is the massive problem known as entity resolution, figuring out when different bits of data are actually talking about the exact same thing.
And this leads us to the million-dollar question for the engineers who built these systems. If there's no unique ID, how on earth does a system know what to merge and what to keep separate? How does it clean up that mess?
This identity problem is everywhere online. So, how did they crack it? Well, it meant they had to stop looking for perfect matches and start thinking in a totally new way.
And the solution is pretty brilliant. Instead of searching for an exact match, we teach computers to measure something called semantic similarity. In other words, they learn to calculate a score for how alike two things are, not just literally, but in meaning and in context.
Here's the basic breakdown of how that scoring works. First, the system compares 2 entries, like those names we saw. Then, it uses a mathematical formula to measure the distance between them. That generates a similarity score. And if that score is high enough, let's say over 95%, the system just goes, yep, that's the same thing, and merges them.
So what does that math actually look like? Well, for text, a really common one is called string edit distance. It sounds fancy, but the idea is simple. It just counts the minimum number of little edits, like adding a letter, deleting one, or swapping one out, that it would take to turn one string into the other. The fewer the edits, the higher the similarity score. Simple, but incredibly powerful.
But of course, it's not a one-size-fits-all solution. You can't measure the similarity of 2 images the same way you measure 2 names. So there are all these different mathematical tools for different types of data: text, numbers, images, you name it. Each one has its own special way of figuring out sameness.
Okay, so computers can be taught to measure this idea of sameness. That's cool. But why is this such a huge deal? Why is this one concept the key that unlocks so much of the technology we rely on every day?
Because being able to untangle all this messy, real-world data isn't just a neat trick for making your Google searches look pretty. It is, and I mean this literally, one of the core engines of our entire digital economy.
Think about it for a second. This is what powers the recommendation AI on Netflix and Amazon that knows exactly what you want to watch next. It's how your bank spots fraud by connecting suspicious transactions that might seem totally unrelated. It enables everything from personalized advertising and predicting user behavior, all the way to helping researchers find breakthroughs in medicine.
In fact, you could make a very strong case that without this kind of robust data integration, most of the AI advancements we see today just wouldn't be possible. It is the foundation that everything else is built on.
So the next time you get that perfect, unified result, whether you're booking a trip or just searching online, you'll know the secret. It's data integration, humming away tirelessly behind the scenes. And that leaves us with a fascinating question, doesn't it? As these systems get even smarter at connecting every single piece of our digital lives, what new capabilities will they unlock next?